In this video, we are going to discuss the part 1 of lesson 6, operations on sets. So lesson 6, this lesson is still part of our chapter 1, which is talks about the fundamentals of sets. So when you say operations on sets, when you say mathematical operations, those are the addition, subtraction, multiplication, and the division. In set, they are also those we call it the operations on sets. So the first operation that we are going to learn is all about the complement of a set. Okay. So when you say the symbol for complement of a set, it's just like this one, or simply the letter C on top. It's a superscript or an exponent. Okay, they mean the same thing. So when you say A, then there's a dash, we say that's complement of A. When you say B and the exponent C, B raised to C, it's like that. We say it's complement of B. So we may also say A like that, or we may also say like that. Different other books use this version, other books use this version. It depends. So what does it mean when you say A complement? Okay, what does it mean when you say A complement? A complement is actually the set of elements that we can find in the universal set. Okay, as discussed before, when you say universal set, this is the set that contains the other sets under discussion. Okay, so suppose we have a universal set, and there is part of that universal set is set A and set B. Whatever limit to the universal set is also the same limit applicable to set A and set B. So meaning, in layman's term, we say if the universal set limits only up to 20, the set A must also limit up to 20, and the set B must also limit up to 20. So whatever limit is applied in the universal set, it is the same limit or the same interval applied to the subsets, any subsets of the universal set. So again, the universal set, from the word universal, it's the set that contains all the other sets under consideration or under discussion. So when we say A complement, these are the elements that we can actually find it in the universal set, but we cannot find it in A. Okay, in A. So that's A complement. List down, we are trying to list down the elements that we can find in the universal set that are elements of the universal set, but but not elements of A. So let's try. So I have here example 1. Our universal set is the natural set of all universal set is the set of all natural numbers. When you say again natural numbers, those we use in counting. So natural numbers less than or equal to 10. To make it more easier for us to figure out, let's try to list down that as 1, 2, 3, 4, 5, 6, 7, 8, 9. We will include 10 because of the word equal or equal to 10. Okay. So then we have other sets. Okay, we have other sets here. A is 1, 2, 3, 4, 7, 8. Then B, we have multiples of 3. So here, look at multiples of 3. It seems like there is no limit, but since B now depends on the universal set, the multiples of 3 must also abide to this limit until 10. Okay, until 10. And the same, so that's multiples of 3. Of course, factors of 10 is already a finite set for letter C. So for us to easily determine this one, so let us say what are the sets in A complement. So we know that the elements in A are 1, 2, 3, 4, 7, 8. We're trying to find the complement of A, meaning what are the elements in A complement. So that's what we're trying to do here. Okay, so what are the elements in the A complement? So what does it mean by A complement again? Elements in the universal set, but not elements in A. So what are those? So 3 Look at this. 4 is an element of the universal set, but it's not an element of A. So that's 1. Okay. 5 is also an element of the universal set, but not an element of A. 6 is also an element of the universal set, but not an element of A. 8 is an element of U, but not in A. Then 9 and 10. So these are the complement of a set A. Okay, these are the sets. This is the set. We call it complement of the set A, and the elements are 4, 5, 6, 9, 10. Okay, so clearly these 4, 5, 6, 8, 9, 10 are elements that we can find in the universal set, but we cannot find them in A. So this set is what we call complement of A. So what is B complement? What are the elements in B complement? Again, let's go back to B. What is that set? It's multiples of 3. Of course, let's abide the limit specified in U, that's equal to 10. So to make it easier for us, let's try to list down 3, 6, 9. Okay, so now let's compare the universal set and the set B. What are the elements in the universal set that we cannot find in B? So what are those? If we're going to look back, we have 1 and 2, of course. So let's write 1 and 2. 3 is an element of U, but it's also an element of the B, so that's not included. 4 and 5 are elements of U, but not for B. 6 is both. 7, 8, we have 7, 8. 9 is not, because it's an element of U, but it's also an element of B. Then we have 10. So these are the elements 1, 2, 4, 5, 7, 8, 10. These are the elements comprises the complement of B, meaning elements in U, not in B. So what are, let's go back, let's go to C. What are the elements of C complement? So we have here. So to make it easy for us, our reference is set C on top. We have factors of 10. What are the factors of 10? We have 1, 2, 5, 10. So to make it easier for us to understand, we say complement is actually the opposite of the complement of C is actually the opposite of C. Okay, so when you say factors of 10 for C complement is the opposite of those that C, meaning those not factors of 10. Okay, those not factors of 10. And what are those? If we're going to continue, let's compare this to the universal set. What are those? 1 is not a factor of, is an element of U, but not a factor of 10 in C. 3, 4, 6, 7, 8, and 9. So that's how we simply find the complement of a set. So now let's go to our next next operation on sets. We have the difference of two sets. Okay. So when we say the difference of two sets, let's just say A minus B, the word difference means minus. Okay, A minus B, meaning this is the set of all elements that we can actually find in A but not in B. Okay, you can find it in A but not in B. B minus A is actually different, surprisingly different from A minus B, because B minus E means the set of all elements in B. It's the opposite. The elements in B but not in A. Okay? Not in A. Okay? So we have here, suppose we have here A, the elements of A are 5, 7, 9, 10. The elements of B are 7, 10, 11, and 12. So let's try find A minus B. What does it mean by A minus B again? A minus B means what are those elements in A that we cannot find in B. So what are those? We have 5. 5 is an element of A but not an element of B. 9. 7 is both an element of A and B. 10 is both an element of A and B. 7 is only an element of A but not in B. So we will include that. So that's it. How about B minus A? So what does it mean by B minus A? B minus A means the set of all elements in B, those we can find in B but we cannot find them in A. Okay? So what are those? We can find 11 in B but we cannot find it in A. We can find 7 in B but we can find it in A. We can find 10 in B but we can also find it in A, so those are not included. 12 is an element of B but it's not an element of A, so these are our elements of A minus B. 5, 7 elements of B minus A, 11 and 12. So let's go with more examples. So we have here example 1. Our set X, the elements are 3, 4, 7, 9, and 10. Then Y are the even numbers less than 10. So to figure it out better, let's try to list down first the even numbers less than 10. So that's 2, 4, 6, 8. So that's less than 10. So let's stop at 8. Then prime numbers for Z, so that it will be easy for us to figure out later. Prime numbers less than 10, those are 2, 3, 5, 7. That's only 2, 3, 5, 7. So what is X minus Y? What does it mean by X minus Y? Those we can find in X but not in Y. Those elements that we can find in X but not in Y. What are those? 3. We can find 3 in X but not in Y. How about 7? We can find 7 in X but not in Y. 9. We can find 9 in X but not in Y. And 10. That's it. So what is X minus Z? Difference of X and Z, meaning those elements that we can find in X but not in Z. Those elements that we can find in X but not in Z. We can find 3 in X but not in Z. We can find, oh, that's it. No, 3 is both for X and Z, so that's not. So let's neglect that. So 4 is an element of X but not in Z. Look at here, compare it here with this one. Okay, 7 is an element of X, and it is also an element of Z, so that's not included. 9 is an element of X but not in Z. Same with 10. Okay, what is Y minus Z? Okay, so now let's consider these two sets here. Let me just, okay, Y minus Z, those elements in Y that we cannot find in Z. Elements in Y that we cannot find in Z. What are those? 4, we can find it in Y but not in Z. 6, can find it in Y but not in Z. And actually 8. That's all. How about Z minus Y? Okay, when you say Z minus Y, what are those elements in Z that we can't find in Y? Okay, what are those elements in Z that we can't find in Y? 3, you can find it in Z but not in Y. 5, you can find it in Z but not in Y. 7, you can find it in Z but not in Y. So that's how we find the elements of difference of two sets. So we will discuss part 2 of this lesson in the next video.